Hi, I'm Matthew Shotton, and I work for the BBC, and today I'm going to talk to you about doing dynamic video in the browser. But before all of that, I want to give you a brief history of broadcasting in emoji. So, in the beginning, people transferred news, knowledge, and stories via word of mouth, and this information would change and adapt over time. Then the written word came along, and this allowed these news, information, and stories to be locked down to a single representation. And this was almost the first form of broadcasting, except it was very, very slow. Then radio came along. And for the first time, information could be delivered to millions of people live from a single central authority. And that was shortly followed by TV, which was very much the same, except we added pictures. And then along came the internet, this distributed network of communication that had the potential to let anyone speak to millions of people. And it was amazing. And a bunch of really good people worked really, really hard. And we learned how to fit the radio and the television over the same pipes as the cats. But the internet isn't broadcasting. It's something different with its own exciting possibilities. And that could be a bit of an existential crisis for a company with broadcasting in its name. So hello, I'm Matthew Shotton. I work in research and development in the UX team at the British Broadcasting Corporation. I love making things as well. This is some stuff that I made. I just put these in because I really love making stuff. So I like physical things. So this is like 3D printers and giant torches and stuff. But I'm going to talk to you today about a software project I've been building at work called the Video Context. So the Video Context is an open source library developed by BBC R&D. And its aim is to make it really easy to make interactive video on the web. Could I get a quick hands up? Who's used the Web Audio API at all? OK, so a couple of you. That's cool. So the Video Context is very similar to the Web Audio API, but for video. It allows you to cut, sequence, and play HTML media elements like videos, images, and canvases. It's also pretty fast. So all image processing operations are done in shaders using WebGL, and it's built using modern, open web technologies. So I'm going to dive right in and show you some code. So this is a full example of a really simple video context composition. So this is HTML document. The video context is brought in at the top. And then we have a canvas, and that's going to be where we're going to render to. So I'm going to zoom in a bit more on this code so you can see what's going on. So we first get a reference to the canvas, and then we pass it into a new video context instance. And then we create some image source nodes. So source nodes in the video context is anything that will output some form of media. So the video context is all graph-based as well. So in order to see the output of these image nodes, we need to connect them to the destination. So the destination is a special case in the video context, and it represents the final canvas that things are going to get rendered to. We then need to sequence these source nodes for playback. So the first image will play from time 0 to time 4. The second image will play from time 4 to time 8. And then we're going to tell the video context to play. So I talked about how it was a rendering graph. This is a really simple representation of that graph. So we have the two image nodes, one from time 0 to time 4, one from time 4 to time 8. And we have the destination, and we have the connections between the two. So this is what that looks like. Some pretty glorious space cats. So this has a bit of extra stuff thrown in to visualize it a bit easier. We have a timeline down the bottom that shows the images being played back from time 0 to time 4, 4 to time 8. And then there's that graph view at the side that shows you when things are rendering. So this isn't so interesting at the moment. It's just two pictures rolling around. So let's make it a bit more interesting. So to do that, we're going to add video. So this is a video source node, and you create it exactly the same way as you create an image source node, but you pass in a link to a video file. You then connect it into the rendering graph, and we're going to set it playing again from time 0 to time 8. And I should say, all of these image and video source nodes are backed up underneath by HTML media elements. So buried inside the image node is just a regular image element, and buried inside the video node is a HTML5 video element. So we've got it playing, and this is what the new graph looks like. So it's a bit more complicated. We've still got our same two image nodes. We have a video node down the bottom, and that's connected to the destination. And this is what that looks like. So this is a bit disappointing. We've lost our space cats. And the reason that's happened is because the video context will render media in the order that it gets connected. So our two cat pictures are still being rendered, but they're being rendered behind Shia LaBeouf. So you might have noticed that Shia LaBeouf was conveniently against a green screen. So I'm going to take a brief aside and talk about how green screening is done. So this is traditionally quite an expensive thing to compute because you need to iterate over every pixel inside an image, test whether its greenness is greater than a certain threshold, and if it is, make it transparent. And this is one of the ways that weather presenters are put in front of their interactive weather maps. So yeah, this is quite expensive. In a 1920 by 1080 image, there's about 2 million pixels. At 25 frames per second, that's 15 million pixels per second we need to process. But fortunately, WebGL shaders provide a really convenient way to do this efficiently. So a WebGL shader is a chunk of code which runs on the GPU. And they're typically written in a C-like language called GLSL. And they describe operations which get run in parallel across many processing units on the GPU. And this makes them perfect for doing simple operations across many, many pixels. So back to the code. I'm going to now create a color threshold node. So this is similar to the source nodes, except it's an effect. And you pass into it a definition. And this describes what that effect should do. We then disconnect the video node from the destination and connect it to the color threshold node. We then connect the color threshold node to the destination. So quickly, I'll give you a brief look into what one of those effect definitions look like. And this is super complicated, and don't worry about if you don't understand any of it. It's mostly shader code. So the bit in the white box is the fragment shader code that does our green screening. So the video context has a bunch of effects built in, but it also is quite a nice environment for playing around and experimenting with building your own shaders. So back to the code. We've created that graph, which looks like this, our two image nodes. We have a video node, which is now connected to the effect node, which is then connected to the destination. And that results in this, which is much better. We can see our space cats again. Oh, thank you. Yeah, so I'm going to take you through that loop one more time. We're going to introduce transitions, because transitions are really important in video editing. So a transition is how you might move from one video clip to the next. So rather than just doing a straight cut, you might have like a crossfade, or you might have a star wipe, you might do something a bit more jazzy. So we're going to create a new video node. And this is created using the same source as the first video node, but we have this value at the end, this 10.5. And that tells the video context how far into that source video to seek before it starts playing back. So this is how you can sort of cut up pre-existing video files, but using this library. So we then create a transition node, and this is really similar to the effect node, except we pass in a transition definition. And then we call transition on it. So this is going to transition from time 3 to time 6, from the first input to the second input of the transition node. We then connect our two video nodes to the transition node, our transition node to the color threshold node, and then we set up our second video node to start playing. And this produces a graph that looks like this. And it's getting a bit complicated now, and it might be a bit hard to read. But it results in this. So we've got Shia LaBeouf being green screened, but the two green screen videos are being transitioned between. But wait, there's more. So as I said, the video context has a bunch of effects built in and a bunch of transitions built in. And this is a demonstration I put together to kind of try and push the limits. So this is 11 simultaneous effects and 5 transition effects happening in real time on full-frame images. And this was rendered live in the browser. And then each one was scaled to fit into this grid. And this really shows the power of shaders, that you're able to do this much processing this quickly in the browser. It's crazy. So other features. Everything I've shown you about the video context so far has been very much set up a processing graph, set up our playing times, and set it running. But it allows you to do everything dynamically as well. So at any point, I could have disconnected or reconnected those nodes. At any point, I could have created new effects. I could have set up new media to be played back. And this makes it quite a rich environment for building interactive video experiences. It also has limited mobile support, which I'll go into in a bit. And if you're into making sort of 360 interactive video, it integrates really nicely with A-Frame as well. So I'm going to take a bit of time now to go through some of the challenges we came up across when we built the video context. And these challenges are pretty agnostic to the video context work, and they'll likely come up if you're trying to build interactive video experiences yourself. So most browsers are limited to about 6 to 8 simultaneous HTTP connections per domain. And if you have many clips to play that you want to play back to back, the naive way of doing this to make sure they all play properly is to create HTML video elements for each of those clips up front and set them preloading. But this quickly saturates the number of available requests to a single domain, and it can make your website really slow and responsive. So the solution to this is the video context will load clips just in time. So all HTML media elements are created about 4 seconds before they're actually needed, which gives it enough time to kind of preload things and get it working. So there sort of needs to be a master clock to sync everything to in the video context. And the natural fit for this would seem to be the video.currenttime attribute. Unfortunately, the rate this updates varies between browsers. So if you're doing things that require frame-accurate cutting between clips, if your current time attribute is only updating every 1/5 of a second, it can break things. So the solution to this was to use a request animation frame as a master time source, which gave us millisecond level accuracy and frame-accurate updates. This doesn't come without its own problems. So if you switch tabs, the request animation frame callback gets halted. And this means, so traditionally on the web, if you're playing back video and you switch the tabs, you'd expect the video to keep playing in the background. But the video context won't be able to do that if it only uses request animation frame. So the solution we came up for this is to, as soon as you switch tabs, spin out a web worker, and inside the web worker run a set timeout loop. And this won't be as accurate as the request animation frame, but it will give you enough timing to keep the video context ticking over. OK, I'm a little bit ashamed of this one, so bear with me. So on mobile, there's no auto-playing video. And this is to prevent videos auto-playing and using up all your mobile data. And the reason for this is all control calls to a video element must originate from, or the first one must originate from a user action in order for a video element to be controlled programmatically on mobile. So the solution to this in the video context is we create a pool of elements with no source. And with no source. And when you call play for the first time in the video context, play gets called on all of those video elements, but nothing happens because there's no source attribute. But it puts them into this activated state where we can then control them programmatically. So the video context then manages this pool of activated video elements. When it needs one, it'll pull one out of the pool. It will use it to play by video, and it'll put it back into the pool. So this allows us to play back video on mobile that doesn't start at the very beginning, but sequences. OK, so finally, this is kind of a biggie. There's no low-level API for frame-accurate sync of multiple videos. And this is kind of a problem, because we have quite complex timing requirements in the video context. We have videos playing on a timeline at any point. We also have offsets within those videos if we're taking a clip out of them. We need to make sure they all stay in sync. The solution to this one Yeah. you got to set them playing and then hope for the best, basically. You can do some quite naive things. So if a video starts buffering, then pause all the other videos and wait for it to start playing again. And it turns out, perceptually, this isn't so bad. Like, people have an expectation of video on the web that it might buffer now and again, which, if in broadcasting world, if that happened, it'd be a massive no-no. But you can kind of get away with it on the web a bit more. OK, so this is the big question. Like, why? Why are we doing this? It's all well and fun. Like, as much as some of us might want to turn broadcasting into cat GIFs and Shia LaBeouf, it's probably not the future, unfortunately. So this is the BBC's mission statement. And of note, it doesn't actually contain any mention of broadcasting, which maybe averts that existential crisis. So in R&D, where I work, our role is to use new technologies in a way that lets the BBC inform, educate, and entertain people both faster, cheaper, and better for now and for the future. And specifically, the user experience team where I work, we use user-led design to create novel experiences to drive technological change. And for this, our tool of choice is generally the web. So I'm going to show you a quick demo video. And this is one of the prototypes we put together building the video context. And we've built a whole range of these, but I'll just show you this one.
Forecaster from the BBC R&D labs demonstrates how a new approach to delivering programs would open the door to more personal, flexible experiences for our audiences. In this demonstrator, we transmit each of the media elements separately, and because of this, we have the ability to control each of these individual elements in isolation from one another. The timeline tracks you see at the bottom of the footage represent the timelines for each media object in the forecast. To illustrate this, you can see how the on-screen graphics can be toggled on or off, or the whole backdrop removed to reveal the raw green screen footage. By delivering content in this way, one of the biggest potentials lies in the enhancement of accessibility. Replacing the standard presenter with a signer is a first-class presence in the video, for example. Or rearranging the on-screen graphics when subtitle elements are present to avoid overlap. You could also change the background map to a higher contrast view to aid the visually impaired. If media were delivered in this way, we could also have the footage adapting to suit your screen size, rather than forcing a single aspect ratio or font size on all devices. Here, we can see how a mobile portrait view would look, with a larger font size and a rearranged view to include more of the map. In the future, we could also link content to your personal calendar or other third-party data services and feature relevant local information. As you can see, the ability to send media elements or objects separately rather than as a single video stream gives much greater flexibility for playback, allowing content to automatically adapt to the screen size and preferences of the viewer. The flexibility of an object-based approach won't just benefit audiences, though. BBC R&D is also testing how it could make production more efficient, giving program makers time to flex their creative muscles in new ways. We hope you've enjoyed this sneak peek into the potential of IP production in the future. This demonstrator does not represent a new service and is used non-broadcast maps and feeds only.
I love that disclaimer at the end. Thanks. Thank you. So in that, you heard the phrase object-based media. And this is what R&D are calling this new approach to broadcasting. And it might feel quite familiar if you've been on the web for a while. But we like to think of it as bringing responsive design to broadcasting, making content that adapts to the user, to the device, and to the environment they're in. And that was one of a bunch of experiments we're building to explore this area more. So finally, as well as a new way to deliver content, the web is a new medium for storytelling in and of itself. And we're really excited to be exploring this area. And we hope that by releasing this library, we make it a bit easier for other people to do so as well. And we're super excited to see what you might make with it. Thanks.